How do we figure out the weight on a load cell without calibration or using a weight indicator? Every load cell has a capacity and a millivolt per volt output. Capacity is the rated load that can be placed on the load cell. The safe load capacity of a load cell is typically 150% of the rated load cell capacity. Load cell output is labeled and described in millivolts per volt. Every volt of power supplied to the load cell proportionally increases the load cell's full-scale output. For example, if we have a load cell with a 3 millivolt per volt output and supply it with 10 volts, we have 3 millivolts times 10 volts, giving us 30 millivolts of full-scale output. 3 times 10 is 30. At full-scale output, in this case, 30 millivolts, will be the voltage the load cell will be outputting with its capacity or rated load applied to it. With that being said, our ratio of load cell output is 3 to 1. Using cross multiplication, we can determine our full-scale output. On the left side of the equal sign, we will place 3 millivolts in the numerator and 1 volt in the denominator, our 3 to 1 ratio. On the right side of the equal sign, we will place our supply voltage, 10 volts, in the denominator, giving volts in the denominator and millivolts in the numerator. We are solving for our full-scale output, or X. To cross multiply, we need to find two real values across from each other. Here we have 3 and 10 across from each other. We multiply 3 times 10 and get 30. We divide by the remaining number, which is 1, and we get our full-scale output, 30 millivolts. That was too easy. So if we know 3 out of 4 of these values, we can determine the missing value. We know at capacity, our load cell will output 30 millivolts. Let us assume we have a 500-pound capacity load cell. Keeping both values in the numerator, 30 millivolts would equal 500 pounds. Perfect. So let's put 100 pounds on this load cell. We are keeping weight on the right side and voltage on the left. Right side denominator, 180 pounds. We are looking for millivolts. X goes in the denominator left side. Back to cross multiplication. Two real values across from each other. We have 30 and 180. 30 times 180 is 5,400. 5,400 divided by 500 is 10.8. X, or our millivolts with 180 pounds of applied load, is 10.8 millivolts. We're getting this. Let's take our known weight off of the load cell. Let's take an unknown amount of weight on the load cell and figure out how much it weighs by measuring the millivoltage. For a millivolt reading, we have 37 millivolts. Left side is our millivolt side, so 37 goes in the denominator. Now we solve for weights. Two real values across from each other are 37 and 500. 37 times 500 is 18,500. 18,500 divided by our remaining value, 30, is 616.6. Whoa, that's over our capacity. You have been weighed, measured, and found watching.